Hi everyone! So today I'm going to be talking about Google Sheet array functions. Now in general terms, arrays are a collection of items arranged in a rectangular fashion. A one-dimensional array can be a row, or it could be a column, and a two-dimensional array are called matrices. So in Google Sheets, these items can't be flowers or cupcakes. A Google Sheets array has to be made up of numbers. So say we want to refer to this array that we have here. Now, if we simply just refer to these cells, Google Sheets is going to give us this error because by default, Google Sheets assumes single values, and it's telling you here, hey dummy, a single value can't span more than one cell. So there's two ways that you can tell Google Sheets to expect the output of a formula to be an array. You can either surround it with curly brackets, or you can use the function array formula. Using Google Sheet array functions will allow you to streamline your formulas. So for example, here is a sales table for our stuffed animal store, and we want to calculate the total revenue as the sales price multiplied by the quantity sold. So the traditional method would just go through each row, price times quantity, copy it down, sum it all up. But an array formula will allow you to write these formulas a lot quicker and cleaner. So then we could just use array formula, B2 to B6 multiplied by C2 to C6. Boom! And if you want the total revenue, then you just add sum to this formula. In fact, this use case to multiply then sum arrays is so popular it actually has its own function called sum product. You can see here, it gives you the same exact answer. So Google Sheets has 14 other array functions, and here they are in alphabetical order. But let's start with these three, which allow you to manipulate the form of an array, are definitely the easier array functions. So Flatten allows you to combine different ranges into a single column array. So here we have three different ranges, and we can use the Flatten function to combine them into one single column array. Now by itself, Flatten is super boring. However, if you combine it with other functions such as split, it can do a lot of formatting automation for you. For example, let's go back to our stuffed animal store and pretend that we're receiving the order counts by customer data in this crosstab format. Now this format isn't efficient for analysis. We really need it to be in this kind of format. But instead of manually copying and pasting, let's try to automate this using the flatten and split functions. So first, let's create each row by combining the arrays that we care about. So that would be the name array, then the product name array, and then the quantity sold counts. And remember, we have to wrap this in array formula to tell Google Sheets this can spill over one cell. You can see how each of these rows is just a concatenation of the values from the original table. However, this is getting a little messy, so I'm going to separate each array with a delimiter. This could be any character, but I'm just going to go traditional and I'm going to use a pipe separator. All right, so now we can more clearly see the different types of data that we're looking at. And then let's flatten this entire output. And you're starting to see the progress, right? This is the in progress state, and this is the final state that we want. See how they're starting to resemble each other? And then the last step is to use a split function saying, hey, divide the text in this cell into fragments using that pipe separator and put each fragment into a separate cell. And again, wrap it in an array formula. The next function is array constraint, which limits an array result to a set number of rows and columns. So I use array constraint to preview really large data sets, and in these cases, it's a quicker alternative to using the query function, where in the query function, you'd have to specify each column that you want in the select clause. So here I can just do array constraint, and I care about this very large data set, but I only want to see 5 rows and 7 columns. The next function, transpose, flips your array on the diagonal so that your first row becomes your first column. Here you can see that example where your first row is now going to become your first column. So transpose is useful for a number of reasons, from formatting to matrix operations. Google Sheets also provides a manual way for you to transpose arrays. So if you just copy your array and then right-click, paste special, paste transpose, you'll get the exact same output, but you should always use the functions when they're available. Just be aware that both these transpose methods are not going to respect formulas or data validation. And so if you see here, you have data validation as your first column, and then you have some formulas. You can see here C13 plus 3, C14 plus 3. If you use the transpose function, they're just going to paste them as values. You're not going to be able to keep that same exact formatting. So these 3 formulas allow you to manipulate the form and the format of your arrays. Now let's talk about some functions that actually do something to your array data. So the first of those functions is the frequency function, which I like to describe as the histogram builder. So let's say we have this order item table, and we want to build a histogram with orders with 1 to 5 plushies, 6 to 10 plushies, 11 to 20 plushies, and then 20 or more plushies. So frequency is going to take your array of your items within each order, take your class as a criteria, and it's going to calculate how many orders had less than 5 plushies, how many orders had 6 to 10 plushies, how many orders had 11 to 20 plushies, and then how many orders had 20 or more plushies. And it builds this nice histogram chart for you. So I use frequency with quantitative ranges, and then I use COUNTIF for qualitative ranges. So the functions I've just covered, flatten, array constraint, transpose, and frequencies, are the more useful and applicable to general use cases. In the part 2 video, I'll cover the modeling and miscellaneous functions, which are for intermediate/advanced use cases.